The first thing, I think someone needs to mute their mics. Yeah. So my question is that, is this statistics useful for a single individual? Suppose we don't have a small sample or large sample. We have only a single individual and we want to find out the spiritual progress of an individual. Will it be possible for us to use our statistical methods? What do you think? So we'll go with that question first. So I need your answer. My question is it possible for a single individual to measure spiritual progress or to measure the health progress, for that matter, or spiritual health or social health, on a single individual? Is it possible to measure the progress, statistically significant or not, in that way? It's a very small group, so you can unmute yourself and tell me. What's your answer, Nirmal? I repeat my question. A single individual and wants to apply statistical test, whether the progress is there or not significantly towards physical health, spiritual health, mental health, like this, on a single individual. What do you say, Nirmal? Is it possible? Randhir Kumar, what is your answer? Or
pardon, please, sir.
My question is that if there is one individual and that individual,
yes, sir,
find out whether the inner progress or the spiritual progress or a physical progress is statistically significant or not, that a person wants to find out. Is it possible to apply this statistical test on a single individual?
I think no, sir.
What others say is Bhavna, Varsha, what others people will say? This is an exam. So let me ask another question. In statistics, what do you mean by population? Anyone? So population is the collection of all possible observation under the study. It's not a population, doesn't mean that number of the people. So it's all possible observations under the study. And if someone says, what is the sample? Then the answer is any subsample of the population is a sample. Then the next question would be whether the sample is random or not random. Then the answer would be, if it is a random, each individual or each observation, right, in a whole population has an equal chance of being selected in a sample. Then it is a random sample. So as a human being, suppose the Dr. Varsha wants to measure her inner growth or spiritual growth, then it is possible. How? So there will be, although the person is individual, there could be various parameters. Say mental parameters, physical parameters, or the parameters as far as the nature is concerned, as the anger is concerned. All those things can be taken, right? And then as a part of the mental health, then there could be a subsets, whether sleep is adequate or not, or whether the appetite is adequate or not, like that. So you'll have the physical parameter, the mental parameter, emotional parameters, social parameters, like that. And all those parameters can be converted into the score. So today you measure your score out of, let's say, around 10 parameters, and each parameter will have a sub-parameters and the score will be there. So if you understood this, that today is, let's say, the 18th October, you have around 10 sets of parameters. In each parameter, there is a score. After 1 month or after 2 years, or let's say 3 months, again, each parameter will have a score. Though the person is individual, but then there are set of observation. The first set of observation and second set of observation, then you'll have one test which you can apply, that is a standard error of difference between two mean. This you can definitely apply. Or if you're going to take measure in terms of, let's say there are 80 parameters, and in that you are taking yes and no, yes and no. And after 3 months, again, this 80 parameters, yes and no, yes, no. In that case, you'll have a proportion, standard error of difference between two proportion, yes and no. This way, you can statistically find out whether the progress is statistically significant or not. This is possible. So when we are doing a study, epidemiology study or any kind of study, statistics can be applied in a particular fashion, and that we can find out. So naturally, if you can find out in one individual, if you have 10 or 15 individuals, right, then you can go for non-parametric test, which we talked about, and you can do your study. And then if the sample size is more than 30, 40, 50, then you can go for the parametric test, provided the sample is relatively homogeneous. So today we are going to look at about the tables, although all of you know it, but it is worth spending 5 minutes or 10 minutes for the reading various tables, because ultimately we need to find out how many people lie in a particular zone, and that will be a decision making for the purpose of policy purpose. So is it clear, Randir Kumar, that even in a single individual we can apply statistical test? Are you clear?
Yes, sir.
It's basically a set of observation, right? So
Yes, sir.
now let's go for the various tables which you should be using for certain kind of estimates. First, let me go for T table. And because most of you people are from the community medicine, you know about the paired observation and unpaired observation. If, let's say there are 20 individuals, their pulse rate before yoga and pulse rate after yoga, then that mean which you are going to find out, the mean difference between these two. Now, once is a paired, the same individual, before and after, this is a paired one. Or you have separate people, are 20 people there, you are giving them tablet calcium, and another 20 people you are giving a food, and you want to measure the serum calcium level. In that case, you can apply you have paired them, then you can go for paired t-test. But if you have taken a randomly, let's say, although the number is same, but if you have picked up randomly from what the population, you have not matched the things, then in that case, unpaired t-test. Either the number is not same or the matching is not done, then we go for unpaired t-test. In any case, you will have a degree of freedom. Suppose in case of paired, you have 10 pairs, there's 10 minus 1, that will be a 9 degree of freedoms. And if it's an unpaired t-test, then one sample is 10, another is 20, 10 plus 20, 30 minus 1, that will be the degree of freedom. Now, in this case, you can see that one tail and two tail. Majority of the time at a UG level, this is not important, one tail, two tail, but at a PG level, it is important. You have a data in which there is no likelihood of decreasing, or there is another set of observation where there is no likelihood of increasing. It is only on one direction. Either it will increase or it will decrease. For example, if you take the parameter in terms of usually what we say that serum creatinine level, as age increases, it will increase, suppose. If we take only those data, then it is a one tail. It's not both the way. It is only we are measuring increase in something that increase will presume that is on positive side. Sometimes if you are giving the medicine, and that's why you presume that it will only decrease. For example, glucose level, it will only decrease, you give metoclopramide. Then when you plot the diagram, it will be on the single side and it will not both the side. At such point of time, we use one tail. Otherwise, by and large, we are using 2 tails. Now, if in this test, in this T table, if you look at the degree of freedom, let's start from the 10. And you look at the 0.05 level of significance. At that time is 2.2. So if the table value of T is 2.2 and your calculated value is, let's say, 4.4, then naturally it will go on this side. And so corresponding P value will be decreased. So we say that if calculated value is more than table value, then we say it is a significant difference. And suppose it is a 10 degree of freedom and the T value is 1.1. So 1.09 like this. In this case, it is calculated value is less than observed value in the table value, then we say it is not significant. But in this case, if you go up to 30, just go at the 30, level of 30. And here, if you look at the 0.05 level at 30, it is almost 2. Almost 2. That means now onwards, it is almost. So what we say that if the N is more than 30, whether you can do a T test or Z test, not a problem. And that's why we say that if the data is not a parametric or sample size is a less, then we go for the T test. While Z test, if a data is more than 30, we are going for Z test. In Z test, equivalent to this is standard error of difference between two mean. So this is how we can use this T table. Any question? So we'll go to the next table as a Z table. Now in this Z table, it is not like this. It gives you total area left side of the value. So this is not a probability. This is also Z value, this is also Z value. So if I say that Z is more than 2, it is 2 and all this more than 2. Right? And in a if it is negative over here, then we can give more than -2. But we get over here the absolute value. If you go for the plus sign, positive sign, Z, then in this case you look at the 2. This is a Z, 1, 2, 0.2, 0.3 like that. And this also you add into Z. Suppose if I want to find out 1.5, I take 1 plus 0.5 here, 1.5. But if I want to have 1.55, then this is 1.5 and 1.58. This is 93943 point. So this is the area under the curve, left side to the Z. So total area under the curve is 1. So what is the remaining on the right side that you can find from this? So let's go for 1.96. So if you take 1.96 and this is a value, this is 1.9. Look at this 1.9. And this is a 0.06. So when we say that Z is equal to 1.96, that time the area under the curve is 0.97500. That means on right side of it, it will be 0.1 minus this 975. So it will be 0.025. So because it is 0.025, if you double it, it will be 0.05. So that is the probability that it will be beyond that, right side means. And you also go for the left extreme. But this table is utilized in addition to that. Once you have suppose it is a 2, and then sometimes it is 1. The question is asked, how many people will be there between 1 standard deviation away and 2 standard deviation away? That means there is 1 and there is 2. How many people will be there out of 1,000? If this is a question, your answer should be this is 0.97725 minus 0.84134. And that will give you the probability out of 1. And then based on, you find out what will be out of 1,000, what will be out of 100, what will be out of 10,000, like this. So area under the curve is important to calculate the number of people likely to be in that zone. Otherwise, Z more than 2, less than 0.05 is significant, that's okay. But this table you should be using at a PG level to find out the number of observation between the particular zone. Any question? I hope you are using this, right? Then the third table is a chi-square table. Anyone can tell me this chi-square table is used for which other test? Anyone? This chi-square table is used for chi-square, but anything else? Forgot about the V and phi. It's used for the Kramer's V test as well as phi test, because in that we use chi-square value to find out that. And that is used when the number is less. It's 2 by 2 table, few numbers, you go for phi test. And if there's 3 by 4 or 4 by 5 table, but number in each cell is less, 3 or 4, something like that, you go for Kramer's V test. Now the chi-square distribution, if suppose there is a degree of freedom is 1, that is 2 by 2 table, then the figure is chi-square is 3.84 is a table value. If calculated is more than that, we say that it is significant. Now, I will just let me tell you that suppose table is 4 by 3. Table is 4 by 3 table. Then what is the degree of freedom? Anyone?
6.
Yes, 6, because -1, -1. Why we do -1, -1? Because once you decide rest of the thing, the last figure you need to deduct from the total. And that's why you have a freedom. How much freedom you have? Column -1, row -1. That is, you have a freedom. That's why degree of freedom is this much. So once we have seen all these 3 tables, we'll move ahead. Now your turn is, let me tell you that you give me one example where you want to correlate the epidemiology, the research method, and statistics together. And before that, as far as research methods are there is a quantitative and qualitative research in that. I'm not talking about the parameter. When we are talking about the population, we use the word parameter, height, weight, or let's say the blood glucose, etc. And when we talk on a sample, we use the word statistic, or we use the word the variable. In this case, when you are going to do the qualitative research, in that you are asking a question, you're taking a detailed history of the case series, you can use the word. And all the description told by the person or the patient, you are writing down in a verbatim, maybe a 10 minutes, 15 minutes, half an hour interview you are taking. Then you go to the next person or patient, such a 20 or 30 patient you are taking, each taking 1 hour or so. And when you want to analyze this data, then you are tabulating as per the theme, as per the topic, subtopic, what exactly patient is using the word, what are the meaning behind that word, or that kind of analysis we are doing, which word is frequently used, what does it represent. So that kind of qualitative research is also important along with the quantitative research, where we only gather the data and then we analyze, etc. So the quantitative research is not enough. It should be supplemented by qualitative research when it is possible. And the students should be encouraged to take that. The only thing that in qualitative research, the data analysis has to be done by the person, him or herself. Because of when you are taking into which kind of meaning you are getting, you may not be aware. Or with the permission of the patients or the person, you record your interview. And from that recorded interview, come back home and write down each and everything. And based on that, you do the framework analysis and putting the number 1 to 30 and then the topics and put the various things. And this you can do. And this is essential. Other thing is the mixed method in which you are doing quantitative study also, but to highlight a particular things, very positive thing and very negative thing, and going into depth, then you can go for that. I will give an example. While we were doing a maternal death study, whenever we go, they have something or other. When we say they died out of delivery, say no, it's died because of heart attack, or sometimes died out because of something. Then we found out why people say like this. Because of maternal death study we were doing, already the government has filled up the various forms, and then they try to train the mother in such a way so that they give a particular answer. So that if a death is due because of heart attack in a pregnant woman, it may not be considered in the maternal death. So such kind of thing you will get only if you go into the depth. That's why sometimes this kind of research is essential. Then comes the combination. When you say the design of the studies across sectional or cohort or control trial like this, no. So the most important as far as the cause and effect relationship is concerned will be triple blind randomized control trial. All of you probably know the triple blind. Anybody can tell me what do you mean by triple blind randomized control trial? So when you
a triple blind study is a study where the patient or the subject doesn't know what is being done. The person who is collecting the data also doesn't know what is being done. And the third person who is assessing all the data, comparing and all, he too don't know what is being done. I mean, which is the disease one.
Then who knows? Somebody has to know, no?
Yeah.
So it's a principal investigator usually is a person who knows what is A and what is B. Otherwise, you're absolutely right. The patient doesn't know what is given to them. The person who is giving, a doctor maybe or a paramedic, doesn't know what is being given. And third one, the data analysis person also doesn't know what is A and what is B. That is a triple blind trial. In that, randomization is very important. You have around 30, 40 or 50 patients and randomizing them into 2 groups or 3 groups or 4 groups or 5 groups. That is the challenge. And usually people know that, no, this the study group and control group. I would say that if you have the energy and if you have enough sample size, etc., then always go for minimum 3 arms in your study. Let's say one is a study group, right? Other, let's say, control group. But then that could be third group. You may use a control too. Also, you can use the word. I think you are doing a study on, let's say, controlling the hypertension. So hypertension and non-hypertensive patient, you are doing something. But then you can take a third group as a diabetic patient, but not hypertension. In that 3 group, you are giving let's say, the various kinds of, that also, not only as a placebo, you can have 3 things together. Placebo 1, placebo 2, and drug. Or the drug 1, drug 2, and placebo. So this time of combination 3 and 3 looks a little bit complicated, but when we are going for a multicentric study, at that time, you will have enough sample. So why not to go for a better strength of study? So usually we take it 2 because no, even the sample of 400 would be most of the time sufficient. But then if you go for 3 or 4 of these things, then in that case, you will have better the theory, better the outcome, and you will say with more confidence, no, this is true. Because there are so various factors. Being patient itself becomes a factor. So when you take a patient and no patient, or between two types of patients, if you go for third group, that will always tell you something. And then this kind of analysis, I will ask another question. I have, let's say, one series of the village in which I am giving vitamin A before and after, right? Let's say before and after means the vitamin A level before the study and vitamin A level after the study, after gap of 1 month. In another village, I don't give vitamin A, but I'm doing before and after study. Now I have this, remember, I have how many groups to compare? Anyone?
Sir, 4 groups?
Four groups.
Yeah, 4 groups. And how many comparison I have?
2 comparison.
2 comparison. So let me use the chat box, even if it is, I don't know whether I have group A. In that I have before and after. And instead of group A, let me call it as the X before and after. Then I have Y before. So many studies are having this data, but then people are confused what to do about this. Now, you say there are 2 comparisons, but I would say there are many. Can anyone tell me? One is comparison between X and Y. Is there any other comparison over here? Yes. Within X, there is a before and after. So there is a third, right? So X and Y comparison, that is 1. But within X before and after, that is second. Within Y before and after, that is a third one. And X and Y after, there is a fourth one. So 4 comparison agreed. X and Y before, X and Y after, there's 2 comparison. Within X before and after, third, and within Y before and after, fourth. Do you agree that there are 4 comparison?
Yes, sir.
And in this case also, there is a difference between before and after in X and difference between in Y in before and after. So there's a 5th comparison. So how much increase or decrease in X and how much decrease or increase in Y. So 5 comparisons are there. Which one you will use for your statistical inference? Tell me that. Anyone?
Only before and after in X and before and after in Y.
No, that is not sufficient, because see, there is something like time factor. If you remove the effect of the time factor, you need to compare the differences between 2 also. And whether the 2 groups were comparable or not before the study, there also you need to compare X and Y. So whenever you have such kind of 5 differences are there, you should analyze all the 5 ways. And that is an ideal. So most of the time we forget this, that when you take whatever you want. So this is essential, all the 5 comparisons. And then you will get the right reason. And then in comparison, if you have these, let's say 2 samples, naturally to compare, that means 2 population where you have taken 2 samples, then see if your data is, let's say, black and white or improve or not improve like that, then you can go for standard of difference between 2 proportion. But if you have something where you can find out mean, then you go for standard of difference between 2 mean, like that.
Sir, if we want to do all the comparisons, is it necessary that the population in X and Y are age and sex matched populations, or there can be major differences between the sex or age ratio? Or...
If we are designing the randomized control study, then it has to be matched. But in case of cohort study, sometimes what happens that you don't have the exact match. You are taking a particular, you are taking America and you're taking India. The population age group differs a bit. So at that time, the standardization is done. there are various methods, direct standardization and indirect standardization, right? So in that case, if you standardize, take up the same age in both the groups, and then if you compare, that will be the best thing to do. The matching is better. But if you don't have the matching facility over there, and you compare the before groups and then both after groups, and before groups almost similar, but then after groups are not similar, then also you can say that yes, even though they were same before, but after they were not the same. That way you can compare two things. And within X, before and after, always you can compare that within that group there was difference or not. And many times people compare their own data, right? In my village, we initially this, and after this. Let's say I will example name of the organization. I would like to. In our area, the maternal mortality was, let's say, around 140, and now we have reduced to around, let's say, 20. But that time might have, the time factor might have reduced from that to this. And that's why, if possible, we should always have a comparison group. And the in this case, with the standard difference to a proportion or standard difference between two, mean that it is on the type of database. But now I give you another set of example, and I'm sure that 99% of you will not be able to answer. The real case series in a boys in class 8. We have a set of example. Whether their marks, their marks in mathematics, take one subject, whether their performance in mathematics, the boys and the girls, then standard 9 boys and girls, standard 10 boys and girls, and their before and after. All these things are there. That means you don't have only one series of data, you have multiple series of data, and in that you have before and after. Then there is a which test anybody can tell me?
Test can be paired t-test. I mean, before and after always.
So in that paired t-test, you cannot, you will not be able to compare so many series things together. When you have, let's say, 3 or 4 things together, let's say class 1, class 2, class 3, class 4, and you have 4 series, and if you want to compare, you have to go for F test. That's the within and between the groups. Within the groups and between the groups, you are comparing, you take F ratio, which is F test, you are using it, right? But even in this before and after, you have multiple series of the data, right? And in that, you have before and after. So in this case, you are going to use a covariance. And covariance test you need to find is a little bit of the job of statistician to do it, but we should understand that in such cases, the covariance is used. And in that case, SPSS is much better comparatively than the Epinfo. So any other question? Otherwise, we'll move up a little bit forward. Anything else? Now, let's go a bit higher. There are something like clusters, right? A group of data or group of observation in a particular region, right? So, at a community setup, when you are, most of you are in the community medicine. So when you want to compare, let's say the large scale studies, 50 villages and another 50 villages, this you want to compare, right? At that time, I'm not using the word cluster sampling. That is only 30. You say the 40 clusters into 7, this is 280, and find out the coverage. Other group also coverage. I'm not talking about that. It's a basically cluster you identify out of this 40 village. Another 40 also you identify cluster. Then you work in the 40 village. Another 40 is taken as the control. This is can also be done to find out the effectivity. And in this, cluster sampling, it will be rapid and still it will be meaningful. Here also, if you have only yes and no, and if you can negate the things, we have seen the loss quality assessment sampling technique, where what do? That you take only 19 objects. And if you can say no in 7, then you're sure that the coverage is not more than 50%. I repeat that out of 19, 7% says that we have not received diabetic treatment. Out of 19 patients, 7 says we are not given a diabetic medicine. So you're sure that in this case, in this, the 19 people are, let's say, taken from 50,000 population. So you're sure that more than 50% coverage is not in this area. So the loss quality assessment sampling technique is used to negate something. That 7 says no, that means coverage is not more than 50%. It says not more than 50%. So somebody is boasting that we have coverage 95%. You go there and find out of 19 how many is covered. You use this table, and then you can find out the probability. And this is the things which can be used. Another question I ask you, that in, let's say in Gujarat, we have 18,000 villages. And out of the 18,000 villages, I have a few districts also, and I have randomly taken villages from 18,000. But it was in the Ahmedabad district, Rajkot district, etc. So let's say I have selected a 40 cluster and 6 individuals in each cluster. I have data up to 40. And some of the clusters, let's say in Rajkot, some of the clusters in the Ahmedabad, other is Jamnagar, like this. What do you think? This data can talk about district, or can talk about villages, or can talk about state? What do you think? You have a data of
about
each
the state. About the state.
So it can't talk about the district or village. It can only talk about the whole Gujarat.
Yes, sir.
Because you are using a cluster sampling, some of the poor, some of the rich, all this will be covered in this. Because when you are taking the villages, or let's say rural area, so rural area of the Gujarat you can say. But if you have taken both rural and urban, then you can talk about the Gujarat. So I think this is now time for all of us to decide some kind of the multicentric study. And it's not necessary that 2 of you will do or 3 of you. Yes, someone at least take a lead, then we'll distribute to all over the India, and let those who would like to participate, let them take a part. Let them participate it, and at least they will represent their own area, if not the whole India. That's what we can do it. So the cluster sampling technique can also be used that way. Then I was thinking that in a committee, when we want to do it, is it possible to teach this AP Info software to a 12th pass person working as a supervisor in a village or a taluka level? What do you think? Is it possible?
Sir, at least they should have some knowledge of statistics and all, no? Then they will be able to understand. Otherwise,
so what do you think?
Terms and all, how will they be able to understand?
What we should do, we have taught in Gujarat the middle level health work also how to use AP Info. In that, you forget the mean part first. Just go only the proportion, right? See, they have gone in the village. Do they know about malaria? Yes or not? And after 3 months, do they know about malaria? Yes or no? And there will be a difference, right? So just if they need not understand standard proportion, etc. Just they go for table commands in AP Info and compare the before and after knowledge about malaria, yes or no, and whatever the p-value. So they know that whether their efforts were effective or not. So sometimes people say that at this level, what is the purpose of teaching them, etc. But the whole purpose of statistics, epidemiology, and research method is to involve the people who are going to take action at their own level. So in village, if they have a problem, and they should be able to find out where is the problem. And then once they know that here is the problem, they will be stimulated to find out why there is a problem. And if you can't go to the village level, then at least a taluka level. If this, see, for example, the CDFO, Child Development Project Officer, or Anganwadi supervisor, or the male supervisor or female supervisor, or if not, at least medical officers should know how to analyze their own data in the PSC. And because all of you might have a data collected from the various PSC, etc. You make the compare across the PSCs. And anybody has used this 2 by 2 table of AP info? Any one of you? I use this, say, I will share the screen. This is table 2 by 2. Have you used this, anyone? Yes or no? Unmute and can tell.
No, sir. No, sir.
So this is a wonderful things, and then you can use this, right? Because in epidemiology, I think the 2 by 2 table is something which is very, very interesting. And if you just understand what does it represent, then it will be simple to explain also. And when you take your the various topics, can anyone tell what is the name of the topic so that I can directly prepare the data and put it over here? And these data you have calculated from the AP info. AP info gives you automatic results, but somebody has already the result ready with you and you want to apply a test, then you can put it over here. Any topic? Can anyone suggest a topic where we can have a dichotomous data, yes or no? Let me put that 7% are the attending the sessions, and the exposure yes and no, around 40 people are not attending the sessions, and the outcome is yes, they pass the exam. It's around, let's say, 20 pass the exam. Here exposes attending, so it is a 14, it is a 7 here, like this, 7. And then yes, pass, not passed. Here the 5 and 20 and 5 and 20. Suppose this is a data, right? The out of 47 who attended, 40 are passing, 25 not attended, only 5 are passing. This is the exposure and outcome data. Now, once you've kept over here, automatically it gives a chi-square test over here, the p-value, then odds ratio. Suppose this is the case control study, you go for odds ratio. If it's the same study, it is a cohort study, then you go for the risk ratio, right? And chi-square test, anyway, you can use it, right? But then if you take another Stata 2, for example, right? Here there's another course in which we have data. Here it is a 30, and then here it is 5. This is not 5. In this case, it is a 5. And here, not attending is a 4. And here it is a 40. Then you see all the data is over here. But when we gave the first, only one table was there, that only one Stata was there, nothing was there over here. But now because this is second Stata is there, it has started giving the summarized result of the exposure outcome. So when we go for the multivariate analysis, right? Or not multivariate, but multi-centric study, at that one there will be third Stata, fourth Stata, fifth college, sixth college, the same data, right? And from that it will give you the the summarized data, and it will give you the range, and then what is the approximate between this lower and upper range, what is the approximate estimate. And this, the word adjusted, right? This adjusted is very important because there are other factors which can affect the things, but because of lot of data, it can find out adjustment. And that's the advanced statistical test, they can do it, right? So we'll be using this 2x2 table routinely also, but particularly when we have more strata, at that time we'll be using this type of data also. And
Sir, what do we mean by stratas, more strata? I mean,
more strata means the various the study setup. For example, you are doing in one college, you are doing in another college, but data is same, right? Whatever your outcome over here is same strata, but their outcome could be different, exposure outcome. The third college could be different. These are the different stratas. And what the Epinfo does, it gives a comparison, or it mixes all this together and then give you the summary statistics. At one point of time, it's not significant. At second, it is a significant. Then what do you do? So there is a series of 6 or 7 data available with you. So all are combined together and statistical tests are given, and it is summarization is given to you.
will we find that summarized and compared ultimate data? I mean,
Yeah, this summarized data is the final data. If you have 3 or 4 data, then you, if possible, you ignore this and accept this. This is a summarized data is more powerful than the individual data. Because at the individual data, there could be inherent some problems. Because of that, the confounding variables, I talked about the confounding variables, that it affects the result also and affects the outcome as well as the exposure also. For example, age, or sometimes the habit of smoking, or sometimes the exercise. When say the poor people are not having the COVID, but at the time the other factor could be they are more exposed already from the beginning, and so that the immunity is more. So such confounding factor could be there. So it will remove those effects and will give the summary result. And in your case, class 1, class 2, class 3, class 4, and you say that their habit of reading early in the morning or late time in the morning is exposure, and outcome is a pass or failure. So 7 classes you take and put the data over here, then that will give you the summarized data. So you should also try to get help. Online help is also available for the stop sharing. I will stop. Online help is also available for the Epinfo, and for each and everything, each command, they have given example how to use it. So there are tutorials also available for Epinfo, which you can use it, and step-by-step tutorial are available in Epinfo online available. There is an Epinfo community also, which you can join if you have more questions, but usually the help and tutorial are sufficient to go into depth of the Epinfo. Approximately it will take your 20, 40, maybe around 70, 80 hours, but then you will be able to do it better way. There are various commands, select command and define command, assign code, so many things you can do with that. You want to put your folder in a particular folder, so output commands, this you can do it. So any other question? So I hope that all of you will prepare the projects in such a way so that it can be submitted to Department of Health Research or Corporate Social Responsibility or any other funding agency, whether it's WHO, UNICEF or something like that, or even the government. Government also wants to do some kind of improvement in the society. So it will be beneficial if you teach to the middle level people, and say you can have an example like this, arrange a Zoom meeting for all the school teachers in your state, and then float the format, and then you will get a data within 24 or at least 2 to 3 days, and you can start analyzing. It's not that research has to be a 1 month or 5 months or 6 months. Even if you have a cross-sectional data, I will give an example. You have a microbiology laboratory. You have, let's say, pharmac also department. You have biochemistry department. You have a patient ID and compressed data. So try to compare between the various variables, whether the eosinophil count versus which kind of bacteria, eosinophil count versus which kind of parasites, or WBC counts versus the diameter of the RBCs, like this. So if you can have a permutation combination, and for that you write down the variable on the x-axis while in the column also, and say which two are comparable, and then you'll be able to find something new, even with the existing data set available from your hospitals. Now, I think the forum is open for questions. I will be giving you the certificates based on the at least 2 or 3 analyzed data, tables at least, and the project proposal. I don't want to see the review operation and everything. I want to see the method which you are using, the population you are choosing, and the sample size and sample technique, whether it's a stratified technique or whether it's a simple random sampling or it's a systematic random sampling. That, and if you have any question, you can ask in the group. Otherwise, probably in the Zoom meeting, we'll be meeting after 1 month. And meanwhile, those who are satisfying the criteria, only 2 criteria. One is write a project proposal, very simple one, and use some at least 2 to 3 tables where you have found a meaningful analysis. Then my purpose is over and I will be able to deliver certificate. Otherwise, when our second batch of our starts, we'll be communicating to you, and you can join in any session. And you have now access to the educational platform, whereby we'll be putting more and more information which you will have access at least for the period of 1 year. And I will be happy to at least see one set of the project proposal. So now the forum is open. Any comments? Any comment? I think no one is there from evaluation. Dr. Kumar, anything you have to say?
Sir, we are already, we have submitted many intramural projects, I mean, in the institute. So
but anyone you can share with us, no problem. The only thing we are interested in, what was your sampling technique and which statistical analysis you did.
Okay, sir.
Because see, our criteria would be, if you even give any golden thing, we should be able to identify some mistake in that. Even if it is a very well designed randomized control trial, you should be able to find out something, some fallacy, some limitation in that study. That is the end of our learning.
Okay, sir. So basically the statistics which I have used personally is all the means and proportions in the numerical values, and basically, sir, percentage results I have taken out and I have calculated p-values. That is what I have done, but I have not used AP info for that.
No, you can use SPS or any method. There is not a problem which software you are using. The only thing, whether your tables are meaningful or not, and whether your study design was proper or not, sampling technique, etc.
Okay, sir.
So we need only 2 things, right? Your study design method rather, and at least 2 or 3 tables, and we'll be able to find out some fault with you.
Okay, sir.
Not with you, with study, so that it can be improved upon. And not a single study in the world is foolproof. So we need to learn how to criticize each other for a better study.
Yes, sir.
And A.B. Hill, if you do not have the book A.B. Hill, short book of statistics, you should have it. And the last chapter in usual fallacies, last also maybe in between there is a one chapter. There is given a beautiful the examples, and then they find out where is the fallacies. And if we learn that, then it will be much better.
Book of Mahajan, sir.
Mahajan is just a book just for the UG level.
Okay, okay.
For the PG level, A.B. Hill is a must, I would say, is a must.
Okay, sir.
Just like a McMahon and Pug in epidemiology, or Taylor and Weldon in epidemiology. Similarly, in the statistics, if you have not read the A.B. Hill textbook of statistics, see, I'm teaching this statistics to you after, let's say, a gap of around 4 or 5 years. Because before Corona, we used to have one offline training every year. And I also feel that there has to be offline, because the interaction and the board and chalk and the discussion with what the people are doing is very comfortable for that. So even after then 4 or 5 years, basics is there because of AB's textbook statistics. One single question might people may ask you, in the standard, we say that a standard error is one kind of standard deviation, right? So in case of standard of proportion, it is a proportion. How come there could be a standard deviation? Or we say the standard of difference between two proportion. How can there be a standard error if standard deviation is one kind of standard deviation, and in proportion there is nothing like mean of the data. So such kind of thing, if you want to answer, the AB is a wonderful book.
Okay, sir. Thank you. And sir, when can we present our study? And
see, now there is nothing like I won't be able to give it. The moment you share now subgroups is optional for you whether to share or not to discuss. But the major group, at least I would request that your 1 page or 2 page on the method of study, and at least the 2 or 3 tables, meaningful tables, which you have analyzed. Based on that, at my comfortable time, I will see it. Mostly within 1 or 2 weeks, I will see that and give a comment in the group. And then I will be giving you a certificate.
okay, sir.
And if you have selected 10 individuals today, or maybe after 10 days or 15 days, I would love to give them access to the educational platform. And then it will be better if you can train those people also. Actually, it should reach to the not only to the UG students, but our paramedics also, so that they can take a decision for their own area. And our second batch will start maybe from 25th October, or maybe a little bit after Diwali, depends on the number of people. So may I take your leave? Okay.
Yes, sir. Thank you, sir.